Good afternoon, students. Let's discuss the method of completing the square today in quadratic equations. It's an important method because it is used at various places, especially when you work on questions on integration and all in class 12. You need this method, and it's a very good method to solve some of the difficult questions. So let's see what is completing the square method. The base of it, the basic concept of it lies in the derivation of quadratic formula, which I discussed in the earlier video. We have derived the quadratic formula, then the relationship between the zeros and the coefficients of quadratic polynomial and so on. So I would suggest that you refer to that video and prepare that thoroughly. Then you will understand this completing the square method also. Suppose I have to solve the question, say 3x square minus 5x plus 2 equal to 0 by completing the square. Yes. And say I have another question, x square plus 4x plus 5 equal to 0. And I have to solve both by completing the square and find the zeros. If the zeros exist, it's not necessary that quadratic polynomial will always have zeros. If the graph of that polynomial does not cut x-axis, it will not have zeros. Suppose you have a polynomial like this, then it has no zeros, because 0 of a polynomial is value of x, which makes y 0, right? So this will not have any zero. So let us find out whether in these two questions we get zeros or not, but we are going to work by completing the square. Now to complete the square, we first need the coefficient of this to be 1. You can work like this, write this as root 3x bracket square, but instead of that you can go parallel to the derivation which we have discussed. So I divided each term by 3. Now this is a square minus 2ab we want. So multiply by 2, divide by 2. So a square minus 2ab. B is 5 by 6. So I have b square. Right? Now just stop here for a minute. 2 into 5 by 6, you will get 5 by 3. So you are correct. Now I added this, so I must subtract this. When I add some term, I must subtract that. And you have plus 2 by 3 as it is. This is a key step. Understand how we got it. First thing what we have done is we have made the coefficient of x square as 1 by dividing the terms by 3. So then you got square of the first term. Now we know the formula a minus b square or a plus b square, anything. A square minus plus 2ab plus b square, right? We are trying to get the square. Completing the square means making it as a square of some terms. So you have square of the first term. Then our formula says 2 times first term, second term. So 2 times first term. Second term becomes 5 by 6 because when I multiply by 2, I must divide by 2. Right? So this is 5 by 6. That means b is 5 by 6. So I added 5 by 6 square. When I add, I must subtract. And 2 by 3 is taken as it is. Right? Now you see this is a square of x minus 5 by 6 square. Right? A square minus 2ab plus b square. Right? That's equal to 25 by 36 becomes positive on the other side. 2 by 3 becomes negative. So if I subtract this, 36 is the LCM, 25. Now this is 12, so 24. That's 1 by 36. Yes, because 12 3s are 36, right? So you have x minus 5 by 6 as 1 by 6 or x minus 5 by 6 as minus 1 by 6. It can be positive or negative. 36 is square of 6 as well as minus 6. So root of 1 by 36 can be plus 1 by 6 or it can be minus 1 by 6. Why root? Because square is 1 by 36. That gives you x as 1 because 1 by 6 plus 5 by 6, and this gives you x as minus 1 by 6 plus 5 by 6, which is 4 by 6 or 2 by 3. That is, we found the zeros of this polynomial as 1 and 2 by 3. Yes, 1 and 2 by 3, they are the zeros, and we worked out with completing the square method. Right? I am going to do that question also. Here we got the zeros. Observe this, what happens. Suppose I have coefficient of x square as 1 now. So I need not divide by any. So a square plus 2 AB, 4 can be broken up into 2 into 2, right? So we did not multiply or divide like in the earlier we had to. Now a square plus 2ab, so b square is 4. So I subtract that, plus 5 equal to 0. Right? I added 4, subtracted 4. Now this is x plus 2 square. This is plus 1 equal to 0. What does it mean? X plus 2 square is minus 1. Now tell me a number whose square is minus 1. There are numbers, but they are not real numbers. They are complex numbers which we will learn in class 11. So here the real roots do not exist. When you get square of something as negative, we should stop working here and write no real roots. No real roots means what? There are complex roots which we will learn afterwards. Here there are no real roots for this, right? And therefore we do not proceed ahead. When we don't proceed ahead, when we get square of something as negative number, we just write no real roots exist, right? And that's the method of completing the squares to solve some of the quadratic equations. Yes, thank you. Work on the method and practice as much as possible. Bye.